Okay, so today we're going to continue factoring trinomials, so 3-term polynomials, but we're going to look at trinomials that have a GCF first, okay? So anytime we factor, so when we started our first set of notes, when we talked about factoring out a GCF, I said it doesn't matter how far we get in factoring or how complicated factoring gets, we always should take out a common factor if it shares one across all of our terms. So you'll notice here I have a trinomial where it shares a GCF across all of my terms. I can take a 2 out of all of these factors. So I can take a 2 out, leaving me, so this is the trinomial I'm looking at, leaving me with 3x squared minus 20x plus 28. Okay, so always I should take that GCF out. And now I'm doing exactly what I did before, right? Where I'm looking at factors of 3x squared and 3 is prime, so I know it's 3x and x. And then factors of my last term, now this is a composite last term, so I'm no longer the 2's out, so I'm not looking at 56, I'm looking at 28. And so I could have 28 and 1, or I could have 14 times 2, or I could have 4 times 7. And so what you see here is just possible ways that this could be factored. Okay, and we look at our OI, same as before. And so here are all the possibilities. Now I know that C is positive and my middle term is negative, so I know my signs. And all we're going to do is run through those possibilities. Is it 1 and 28? Is it 28 and 1? Is it 2 and 14 or 14 and 2? 4 and 7 or 7 and 4? And we're looking, thinking about all these possibilities, looking at this outer inner, and we know we want it to add up to what? Well, let's go back to our trinomial. We want it to add up to negative 20x. So let's go through, let's look at our terms here. Negative 20x. And I would say right here we have a winner, right? If I were to look at the OI here, that would give me negative 14x and negative 6x, giving me negative 20x altogether. None of these other factors would work, right? This would be negative x and negative, oh, I don't know, negative 84x. That's not going to work. This would be negative 28x and negative 3x. That's not going to work. This would be negative 2x and negative 42x. That's not going to work. So once we get to a combo that works, we're like, ding, 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 this is the one. Okay. So it's just organized in a table here. See what happens. If we were to try all the possibilities, there's only going to be one that works. And eventually this process becomes all mental, right? We don't even have to write in the outer inner. We're just kind of mentally checking what combo is going to work. Also notice that the GCF of 2 that we factored out at first has no effect on the binomials. So once we take the 2 out, it's there, it's still floating out front, but when we're factoring, we're now looking at this trinomial. It's not affecting, that 2 is not affecting how we look at it. Okay, so let's look at another example. Now this time our GCF is not an integer, but instead we look and we go, well, they all share a factor of x. So I need to take a factor of x out first. Now let's see if I can factor what's left here. And 8x squared, so could either be 8x and x or 4x and 2x. Let's start with 4 and 2 and see how we do. Negative c value, so I know I need opposite signs. And I have a prime last term, so 3 and 1. And we want it to add up to negative 10. So if I go 3 here, 1 here, negative 3, positive 2, that's going to give me negative 12, positive 2, adding up to negative 10. Here are my correct factors here. And again, that GCF that I took out, it doesn't go away, okay? But it also doesn't affect what I'm now looking in here and factoring what's left, okay? So let's look at a few examples here, and we're just continuing to practice factoring. So first of all, does the first one have a GCF? No, it doesn't. Okay, so some of these are going to have common factors we're going to take out, and other ones won't. So here I don't have a common factor. I'm just going to go, okay, let's see if I can. In some trinomials you can't factor. Okay, those we call those prime trinomials. Okay, so we're seeing if we can factor this trinomial. So 6n and n, 3n and 2n, those are my possibilities. I'm going to start with 3 and 2. I know I should have opposite signs. And 7, it's going to be 7 and 1 that I use, and I'm trying to make 19 with opposite signs. So if I go 7 here, 1 here, positive 7, negative 1, that's going to give me positive 21, negative 2, giving me that positive 19. Then I look at my next example, and before I start this, I notice I can divide them all by 10. So I'm going to divide all of my terms by 10, factor a 10 out, leaving me with 3x squared plus 13x minus 10. Now this is going to be a lot easier to factor too. Okay, so 3x is prime, 3x and x. I know I have opposite signs. 10 could be 10 and 1 or 5 and 2. And I need the OI to add up to 13, opposite signs, so be careful here. I don't want to go like 10 and 1 and use same sign to make 13. It has to be opposite signs. That's where you got to be really careful. That's tricky with our signs there sometimes. So I actually want 5 and 2, which is going to give me 15 and 2x, positive 15, negative 2 there. That's how I get with opposite signs, 13 in the middle. Okay, and it's not factored, it wouldn't be factored fully if you had left that GCF in. Then you'd have a GCF in one of your, or possibly in both of your binomials, and that would be considered not fully factored. So we always first look, is there a GCF? Take that out, and then continue to try to factor those terms. So if you flip this over, there's just a few on the back. Let me do a couple of the challenge ones with you, and then I'll let you work. So really, let's do, you know what? I'm going to let you work. And then when we come back together, we'll do 12 together. Okay. So take some time, try this where you're first looking, is there a common factor? Take that out and then factor from there. Okay, so let's just talk through these examples on this back page. So on our first one, we can take a w cubed out and you can factor what remains. And here's my fully factored version of that polynomial. On number 6, I can take a y squared out. And again, I can factor what remains. Here's my fully factored form. Now on 7, I took a factor of 5 out. And I can't factor what remains. So my only options for my last term would be 9 and 1 or 3 and 3. And because it's a positive C value, positive middle term, I know it's plus plus. And there's no way that I can place those in there and have this OI to just be 2. So this is as far as I can factor that particular polynomial. Okay, all I can do is take a GCF of 5 out and then I'm done there. It doesn't factor any further. On 8, lots of options here for your last term. Here's my factored form. Take a 2 and a y out. On 9, there's no GCF, and that's a little tricky. Instead of 5 and 3, we're using 15 and 1 for the leading term factors to make that way to positive 13. And on 10, I can take a y out and factor what remains. And on 11, no GCF there. I just factor those terms. Again, looking at the OI to determine where to place things and what to do. I know positive C value, negative middle term, negative, negative. So now let's look at 12 together. So looking at just the integers, I can divide a 2 out of all of my terms. And then least variable, so I can take an x cubed out and a y squared from each term. That's going to leave me with 8x squared plus 33x plus 4, okay? And now I still have that 2x cubed y squared out front. I'm going to factor what remains. And so 8x squared could be 8x and x, or 4x times 2x. And like I said, I normally start here, but if you had put in 4x and 2x, positive c values, so you know it has to be plus plus, I think we'll quickly realize this could be 4 and 1 or 2 and 2, that there's no way to put that in there and get a number as great as 33. So it's not going to be 4 and 2. I'm going to use 8x and 1x and factors of 4 to make this be 33 in the middle. I'm going to have 4 here, 1 here. That gives me 32 plus 1, giving me 33 for my middle term.